I urge you, do not be troubled, be frightened, be led to scare by this strange music which emerges from this strange old place. I am Professor Julius Sumner Miller, and we are doing some physics with a flask and some colored water in it, and we need to learn a little language. When is a thing elastic? A thing is elastic for physics as follows. If when compressed or distorted or deformed, it recovers completely, then it is said to be highly elastic. Steel is highly elastic. Glass is highly elastic. This is sometimes called an elastic band, but it is falsely called. Proof. Let me measure that new elastic band, so-called, precisely. Let me measure it. 3.73 centimeters, let us say. Now I'm going to deform it. And now I'm going to relax it and measure it again. I assert that it'll be longer than before. It has not recovered. So this is falsely called an elastic band. I sometimes go to the secretary of my department and say, my dear lady, will you give me some inelastic rubber bands? Oh, she says, Professor, we don't have any. We have elastic rubber bands. And then I blow my stack because she does not have any elastic rubber bands. There are no elastic rubber bands. Glass is highly elastic. Steel is highly elastic. Proof. Here I get in a prayerful mood, and here is the level of the water in this tube, right there, and I'm going to ever so gently squeeze the wide faces of the bottle. There, look at that, ever so gently. Yeah. So clearly I deformed the bottle, which being elastic recovered, and if we look sharply at the level now, it would have recovered completely. Now, what happens when I squeeze the narrow sides? Now, I asked that question, I think, on an earlier program, and I invite you to contemplate the reason for it now going down. Watch it. There it is. I'll have to squeeze it. There it is, and there it is. Yeah. Now, the first case I will make clear, and I will leave the second to you. There's the original configuration, and when I squeezed the wide sides, they took up that geometry, the volume was less, and the liquid had to go somewhere. This demonstration shows us that water is highly incompressible and glass highly elastic. Here I have a flask, bottle, nearly completely filled with water. Not quite. There is a bubble in it. That's a little too high. There's the bubble. There's the bubble. I'm using this as a spirit level. Now, I say that if I squeeze that glass, I can compress that bubble because gases are compressible. It'd be difficult to see. Yes, it smalled up a bit. It got a bit smaller. Yeah. Now, a commentary. I warn you not to do it because it is a dangerous experiment, but it could be done. If this bottle were filled completely, notice how emphatically I say it, completely with water from which all the occluded gases have been driven off, if this were filled completely, I could, with absolute immunity, use this to drive nails into a block of wood. Why? Because the glass is highly elastic and the water highly incompressible. But with the slightest bubble therein, the glass would yield, the bubble would yield, and we would have disaster. And so, we shall return another day with some more enchanting things to inquire about.